So now we got ourselves this question. Let's find a way to solve it. Okay, and if you remember, this is the formula that we're going to use. It's actually equal to 0. So we're going to make use of these two formulas. Okay, and we call them characteristic. Okay, characteristic equation. So let me just move it. Okay. Thus we do it. Okay. Let's find the determinant. So let's solve for A. And before we get to that, let's start with okay. This is what we get when we look for the determinant of and then this will give us let me just to move it, and then we get 4. It's actually 1 here, not 4. If you times this one, which will give you 4 negative 2 negative 2 and then square. So there's one thing missing. It's going to be negative positive square. Okay, and then negative 1 here. So, and then if you carry on, you could see those two are identical, so which will give us, and it will be 4 negative 1. It's going to be 3 minus 4 plus square. And then let me just rearrange this This is when you solve for the delta. Okay, let's rearrange this. So it's going to give us something like this: -4 plus 3 equal to 0. So all of this just equal to 0. Then when we get to this phase, we need to find delta. So and then it's minus b to a positive negative b square minus 4 ac. And it's similar to, if I just open this one, we can see this is where we have a, okay, plus b plus c equal to 0. So I'm going just to replace the value. So b, it's actually -4. So it's going to be -4 plus negative, and then b it would be -4, -4 times a which is 1, and then c which is 3 over 2, and a equal to 1. And the answer that we get from here, it will be 3 and 1. Okay, so that's our eigenvalue that we just got. So what we know that eigenvalue, we get this one and then that one. So those are the two eigenvalue, and then we plug them. We're going to work with this second formula. Okay, and then let me replace the value that we have, and remember we have this one. Okay, okay, we got something like this. So if I have to represent this one, it's gonna be times x y equal to 0 and 0. So we got ourselves this block. So we need to solve for y prime eigenvalue 1. So what we're going to do here, so we're going to replace the value of 3 inside. So we have something like this: 2 negative 1, 2 negative 1, and then x y equal to 0 y. If I have to replace, so we're going to have 3 here, 3 there, then which is going to give us -1 1 1 -1 x y equal to 0 0 0. Okay, so we got ourselves this form, and then what we do next is we're going to take this block and make it equal to 0. So we have something like this. So let me just okay, let me just copy it, okay, and replace 0. Okay, and after that I'm going to multiply this matrix, this column and that row. Okay, and what I'll get to be x negative x plus y equal to 0. Then I'm going to solve for, so it will be x equal to y. So if I get this form, that means we have 1 times x equal to 1 y. So that's what you see. Let me just write it in a form with a different color. So meaning what we just got here, that means for the eigenvalue of 3, the answer that we got of x and y, it's 1 and 1. That's what we got for, this is what we got with the first one. And then let's work out the second, which is 1. Okay, we're going to go with the same principle. Okay, this is what we're going to solve. Okay, let me continue. So this is what we're going to plug here. Replace the value of eigenvalue. So 2 negative 1, which will give you 1. 2 negative 1, which will give you 1. Then this is what we're gonna have. You're going just to rechange this last row with 0. So we get something like this, and then from there we can multiply. So it's gonna give us x plus y equal to 0. And then from here we can solve out for, then it's gonna be negative y. Okay, and after we got to this, we can say for eigenvalue of 3, we got x and y. Okay, we can even write it the other way around, but since we see x equal to 1 and y equal to negative 1, so this is the answer to this to the second one. And then if I have to write the model matrix, so it will be okay, it should be 1 1 and 1 negative 1. So okay, this is the answer, the first one and second answer that we get from this question. So this is in any way a way that's for you to solve the eigenvalues and then the eigenvector. So this one are eigenvector.